For today's software engineering interview, we'd like you to explain multithreading. Okay, let's say a user wants to do something like compress multiple different files. With a sequential program and one singular thread, the CPU has to compress one file at a time. If each compression takes 10 seconds, this total operation will take upwards of 40 seconds. Now, assuming we have a 4-core CPU, the CPU can execute 4 threads at the exact same time. So now we can be compressing all these files at once and our job will only take around 10 seconds, much faster. What if the user wants to compress 8 files? Do we just use 8 threads? Okay, when we have more threads available than CPU cores, the CPU does something called context switching to execute these threads. The way this works is your core will basically work on one process and then switch over to the other one and keep doing this back and forth. So it's not actually executing the job at the exact same time, but you get the illusion that it is because it's switching between them so quickly. Now, as you can imagine, the act of switching between different threads actually takes time. So if we only have a 4-core CPU, going to 8 threads will slow down our process instead of just using 4 threads, finishing up the 4 jobs in parallel, and then finishing up the next 4 jobs in parallel. So would you ever use more threads than cores? Let's say we want to do some web scraping on multiple websites. The slow part about this is waiting for the network to respond to our requests, not making the request themselves. With one thread, we can send a request to each website, wait for it to respond, and then send a request to the next website. This total operation would take about 4 seconds for all of these websites. So we're just going to use 4 threads here again and wait for the first 4 to complete. So with 4 cores, we can only be working on 4 things actively at the same time, but with something like web scraping, we don't actually need the CPU to do very much work. It can just start all 8 of these jobs with 8 different threads, and then it doesn't matter if the CPU is switching between the threads because it's not actually doing anything. We're just waiting for these network requests to get back to us. This means that for IO bound tasks, going with more threads than cores is actually a very common and great strategy to speed things up.